For the third and final part of lesson 12.3, analyze geometric sequences and series, we're going to look at finding the sum of a finite geometric series. So as long as it's finite, it has an ending. If it's a series, we can go ahead and find that sum. A bunch of terms added together, we can figure that out. So our first example, we are told to find the sum of the geometric series shown here. So this is written in sigma notation. Our lower limit is 1 and our upper limit is 6. So we're looking at the first 6 terms, and each term is based on this rule: 4 times 3 halves to the I minus 1. So 3 halves is our common ratio. 4 must be our initial term, or first term. Now you could type that into your calculator using your summation key. No problem. You'll get an answer. It'll be fine. What I want to show you is that there's a particular rule that you could use instead of typing this into your calculator, instead of having to do it by hand. A rule comes into play for some other things that we do later on. So we'll show you. You'll probably type in the calculator. That's okay, but understand this is going to be useful for other things. So to find the sum of the first n terms, in this case I'm looking at the sum of 6 terms. According to my rule, I'm supposed to take the first term. Well, the first term in this series, because it's geometric, I know I can pick it out. It's going to be 4. I multiply 4 times 1 minus r, the ratio, which is 3 halves, raised to the nth power. Remember, n is 6 because it's 6 terms worth. And I divide that expression by 1 minus r, just all by itself, 1 minus 3 halves. Now, this is kind of a big, ugly expression, and you'd probably be typing this into your calculator anyway. 3 halves to 6 power is some fraction. 1 minus that divided by, this would be negative 1 half at the bottom, times 4. To save you time, I know you're just typing it anyway. You end up with, this is a decimal, 83.125. If you change that into a fraction, because you prefer that, it turns into 665 divided by 8. Either way, that's the sum that you should get. Now, go ahead and type it in using summation notation. That operation on your calculator should give you the exact same thing. Go ahead and check it to make sure. But this would be the formula that you could use if you chose to do so. Now, I'm going to do one more example here. This word problem, we've got a bunch of skydivers in formation. So in the first ring, there are 1, 2, 3, 4, 5 skydivers. In the second ring, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 skydivers. It looks like we're told that in each ring after the first has twice as many as the preceding ring. Okay? So if that's the case, let a sub n be the number of skydivers in the nth ring. Okay? Find a rule for a sub n. Well, if we're going 5 and then 10 and then twice that would be 20 and twice that would be 40, etc. The rule looks like we're going to have a common ratio of 2, right? We're doubling it each time. And my first term is 5. So I take 5 the first term times 2 the common ratio raised to the n minus 1 power. And that looks like it's going to be a pretty good rule. So letter A, you're taken care of. Part B, find the total number of skydivers if there are 4 rings. Well, I already wrote out over here 5, 10, 20, and 40, and you could just add those together. No problem, right? Or I could use summation notation to do this. I could say n is 1 through 4 of 5 times 2 to the n minus 1. I could type that into my calculator, get the same thing. Again, adding this, obviously 45 plus 30 is going to be 75. So you should get 75 by adding them up by hand. You should get 75 if you use sigma notation. If you were to use our rule that we just learned before, the sum of the first 4 terms is equal to the first term 5 times 1 minus the common ratio of 2 to the nth power, which is 4, all over 1 minus the common ratio raised to nothing. Well, let's think about what is this going to be. 2 to the 4th is 16. 1 minus 16, that's negative 15. 1 minus 2 is negative 1. So we take, we take negative 15 divided by negative 1, that's right here. That's going to be positive 15. If I take 5 times 15, which is what that is, I end up with 75. So the same thing that you get if you just simply add them by hand up here, or if you use sigma notation, no matter what, there's 75 skydivers in formation. Hope they don't fall and break their legs. And that's it for lesson 12.3. Good luck on your assignment.